Hello and welcome to MBS TV. We're here today to talk about architectural finishes on concrete. And I'm delighted to say that David Bennett of David Bennett Associates is here today to guide us through the subject. David, thanks ever so much for coming in. Can we please start perhaps with the idea that concrete as an architectural finish is quite a new thing, isn't it?
Well, there was a great surge in interest in the early days when it was invented, and the idea was it was a panacea to do anything. So almost like wallpaper, and lots of buildings were done. The 16s, it became so dominant that almost architecture and materials lost sight of the ultimate vision. It is a material that does decay and get dirt stained. And that the legacy was left, and that there was a view that it was not a build material to show on the surface. And the perception was at the time, and this was even promoted by the CNCA, that only precast could be an exposed concrete finish. And yet we saw the works of Ando and others producing fantastic finishes. And as a result, people, the names we know, the modernists like Foster's and others, reinvented their own architecture with this idea of having this planar surface which looks like liquid stone.
David, there's two types of specification commonly used. There's the NSCS 4 and there's MBS's own specification. But I believe you prefer more of a bespoke approach, don't you?
Those are very good working documents for generic things. Broadly, they cover the whole aspect of structural concrete, which is not the surface finish, which is treated rather as a superficial entity. But the superficiality is really like the cloth you wear and the style that you got, and it's very, very individual. And you can't really write chapters on it. So you use the building blocks from the NBS for the structure, but for the visual, it's quite prescriptive and quite focused as to the color of the finish, the materials you're going to use, and then the workmanship attached to it.
So what would you use, for example? What are some good documents to help steer people?
Well, in the early days, there were a series by, which was the CNCA, now the BCA, Appearance Matters. That was then taken further by the Concrete Society's Technical Report 52, Plain Form Concrete Services. I often feel they were a bit lacking because they were driven by the construction industry who were trying to do standardized things. What then I did is explore why we are not looking at the whole range of visual concrete finishes. So having researched two books, the Architectural In Situ concrete book is a summary of my findings in Europe, in the world, and then bring it back together to produce the backbone of a specification that an architect should use to develop. There are other reports. I'm in the Concrete Centre have produced some succinct pieces of information, and they're useful knowledge base.
Is there a minimum amount of cement that should be used in each mix?
If you don't have enough saturated material, which is the finest particle, cement, you won't get a good solid colour. That's it.
And how much are you talking about?
Well, it varies between 325 and 350. In the past, because our mixes were predominantly ordinary Portland cement or OPC, the jargon word is SEM1, 325 was okay. But now we're using lots and lots of replacement cements, PFA, pulverized fuel ash, and GGBS. And I think you need
GGBS,
which is ground granulated blast furnace slag. These are replacement cements, and therefore you need a bit more cement content. So 350, I think, is a nice number. It could be 340. But you start with that to say there's your minimum cement content for good color saturation. At the same time, you also have to comply with the structural requirements for minimum strength. So those must satisfy the two.
So what colours normal concrete then?
Basically, the finest particle, which is water, but it's transparent. But that actually is the tonal color. So you have a glass of orange juice and you put some concentrated orange in it. As you increase the water content, the tonal color lightens. What we must do is not have it change. So we start, I'll talk about the water in a minute, but the base color is the cement because it's the finest particle. So the cement must be from the same source, because I think there are 18 different ordinary Portland cements in Britain, and they're all different shades of grey. Every time you're in a different region, a ready-mix company will only use one source of ordinary Portland cement. So you start with that, but at the moment they all are replacing the OPCs with pulverized fuel ash or granulated blast furnace slag GGBS. The reason for that is money. And therefore you can get a GGBS is off-white, PFA is charcoal grey. These actually have a major impact on the final colour. So you can have a building, if you are not aware of it, as some architects aren't, you might find one building that's dark mid-grey and the other one's quite pale. So the same money. And then it's affected by the water and by the other fine particle, which is the sand or the fine aggregate. If, for instance, you had a yellow sand, you put a nice yellowy tint to the grey and it's a warmer colour. I do know when architects have a choice of a crushed grey fine aggregate as opposed to a naturally washed river sand, they said, this is so warm, and I said, that's the tint of the yellow sand coming through the grey, whereas the other one tends to look a bit steely grey. But I can tell you, I'll put another architect in front of it and he'll prefer the other one. So it is very much subjective. The ready-mix companies are a little bit reluctant, a lot of them, to put in an additive pigment. The costs are very high, and the other thing is the removal of that remaining concrete in the truck mixer. It leaves them with headaches because they are recycling a lot of the tailing water into the next load. So the next customer does not want to see sort of streaks of sort of green and blue hints. Plus, the other thing is the price of ready-mix concrete will double or treble by using a pigment. And small amounts of it do have big variations in tone. So what I do say to architects, if you want a pigmented in situ concrete, it'll have quite a lot of tonal variation. It won't be solid, as you might expect with precast.
David, how do you ensure that the mix is consistent?
Sounds very basic, but the cement colour must be the same. So wherever the ready-mix company is, they must buy in the same ordinary Portland cement, which they will do, and the same PFA or the GGBS, and that's the starting block. The next part of it, there's a critical ratio between all the materials, but the significant one that gives a tint to the whole grey is the colour of the sand, and so or the fine aggregates, and that must remain the same throughout. So as long as you inform them, they're fine. If they have 2 or 3 sands or fine aggregates available, the architect has to go and actually say, I like this one, it's lighter or darker. They will know. And then the next thing is we try and make sure the water is the same for every load. Because as you vary the water, the tonal colour goes lighter or darker in shade. And the way to do that is to control the particle size of the coarse aggregates, because they have a biggest influence on the amount of free water that's added. Having got that, you then say, how do you mix it? And more truck mixers have drums which are called agitators. In fact, they don't mix concrete very well because the blades are quite small. And they need, it's called a wet batch or pre-batch mixing facility at the ready-mix plant. If you do that, to me that's perfection in mix control. So we always look for a wet batch or pre-batch plant, but sometimes they can't. So then when we look at the drum of a truck mixer, like I'm doing at the moment on a project in Essex, from the beginning to the end there's a bit of a variation in the consistency of the concrete. So we make them stand there and rotate the drum for 10 minutes, which they don't like to do.
The choice of the form face is really important, isn't it? Tell us about that, please.
It is everything. Often I ask architects, what's the most important factor in producing good concrete? And they forget the form face, and I said, that is the cloth of gold. You've got a liquid stone. Once it impacts on that surface, that's the quality. If you've got a beautiful mix with an awful form face, it's awful. Currently there are generically 2 types of form faces. The matte, which is called a medium density paper overlay, which has some resin. And the other ones are the shiny face, they're called phenolic resins. And they're brown, and the impact of those are, they highlight every defect. And so if you have a soffit, when you have certain rust stains or scratches, they are much more visible. And then if you want to remove the rust, you take the shine off. So I often say to them, for a soffit, start with a matte finish. So if you do get a problem with any defect, you can actually repair it. Otherwise, you have to remove the whole sheen of a phenolic resin for a soffit. So the answer is not to use it for certain places. The quality of these materials also mean that in the finish, a matte finish is much more forgiving.
And the way the architect specifies the layout of those sheets is also crucial, isn't it?
So the first rule I say to them, please look at standardized materials which are readily available. When you come to a construction joint or a column line, cut the sheet on site, and then put a shadow gap as a make-up to hide it. And that's where we get over soffits and we get over walls and other. And the point is the lines then become very minimal. The next rule is you should not fix on the face, because a lot of contractors likes to use a nail and crucify beautiful wood, because the film's 1/2 mil thin, and if you put a nail through it, you split it. And then that nail rusts and it creates a hole and you get watermarks coming through. So I said the best thing to do is to back fix it, having a backing sheet, and then the sheet itself is unmarked and you have multiple uses for it. The soffits are damaged by foot traffic and rebar. And if you just put your beautiful facing sheet on the top and throw rebar on it, you destroy it. And I've seen so many beautiful projects ruined that way. So the idea is to have an under sheet to walk on and to drop things on. And when you do the top sheet, which comes on it, you walk on it with carpet slippers, literally. Now, the first thing is try not to drop the tyre wire on there. So the strategy is, why don't you do as much off-site fabrication as you can, even on the building site. So you bring it up with welded or tied mats and minimum tie wire. The next rule is there is a little twill wire with a gizmo, which ROM have and others, which like wrapping parcels. You can put this bit of twill metal, it wraps itself round rebar, and you just turn it down, but you don't cut the end. So you don't drop wire onto the surface, because all those will rust.
The tie bars that hold it all together and the pressures that are exerted on them, that's also crucial to getting a nice finish, isn't it?
The biggest problem's always in vertical work, where the hydrostatic pressure is a lot greater, and there's formwork movement. So the first thing is the tie cone itself. The plastic tube you see with the tie rod going through with a cone, that is a compression strut. So what happens, you've got a wall, maybe it's 300 wide, you've got the form face up both sides, the tie goes through, and they're tightened. And that cone is a compression strut. It just pinches finger tight against the form face. If it's a thin, cheap old cone, it starts splitting quite quickly. If they don't cut the tube perfectly square, it rotates. So the first rule I say to them is put a gasket on the cone, get it finger tight and get it right, and have a decent cone there so it doesn't buckle. That eliminates a black water marks you get on a lot of ties. That's a common problem. Very difficult to get rid of it because just little water's leaked. And the other thing with the cheap tie cone, they can slightly over tighten and split it. And once the tie cone's split, you lose the definition of that lovely round hole. That's one. That's a common fault. The bottom two ties, when we're pouring at winter time, the loads can be quite high. And the simple thing to do is to put a bigger DB-DAG rod in it. But if you don't check it, they don't, and they, starting in summer, getting great results, and winter, the tie extends, maybe at the contact face by more than 2 to 3 millimeters. The cone stays there, the actual formwork moves, and then you get this honeycombing at the bottom, because you've lost all the grout, lipping, which I call shirt hanging out your trousers. And that really is it spoils everything. And the way to eliminate it is to design the tie bolts properly to take the proper pressure. So I refer back to temporary works designers, use Syria 108, look at the pour rates that we have to do. To pour vertically, you need to go at 2 to 3 meters an hour. That gives you very even color. And assume site temperatures in winter are 10 degrees. And then that gives you the pressures to design to, and then it's normally the bottom two tie bolts.
And the release agents, when you see those guys squirting stuff on site, that's a very important consideration as well, isn't it?
There are two schools of thought, and it's a bit like if you've got a lot of hair, some people like to sort of blow dry it, and the others like to slap on a lot of Brill cream. Well, I think the blow dry guys are winning the day, definitely. Girls fancy them. I have to say the finish is far better with a blow dried finish on concrete, because the less release agent you put on, the better the surface finish. And the gilt they have on site, the more they think they put on, the better the surface. In fact, it kills it, because the release agent, the good ones, retard the cement hardening. And if you put too much on, and I have to say about Canadian ply, they are a lot more transparent, and their membranes, if you put too much on, soak through to the backing plywood, and you get the reflective patterns of ply grain on the surface. And then as you pull the forms off, you take off this very fine skin of finish you're looking forward to seeing, and you remove it. It's like taking a bit of your skin away, and you see lots of grain and a huge amount of holes. So the rules are spray it on and wipe it off with a cloth and if you put your finger in it, it's still running and getting marked, you've got too much on. That's the rules of how to do a good release agent.
The poker vibration is really important, isn't it? Tell us how that should be done properly.
You can't throw concrete from a great height, but unfortunately they have to, because there's an annoying thing like reinforcement getting in the way of a wall. So the contractors don't think about placing tubes halfway down, because what happens, they'll drop the concrete from the top, it hits the rebar, the stones scatter to the bottom, the mortar sticks to the top, and we get a lot of holy moly concrete which is very, very open textured. It's honeycombed. Because the stones are gone, there were not enough mortar. The second thing that I found happens if you throw it from a great height, in the summer particularly, the mortar splashes hit the formwork at the upper level. They dry as little particles, and they've already hardened by the time the concrete comes, and they can't pull them off. And we get millions and millions of little holes. So placing is critical, that we avoid touching the rebar. You have a flat hose or a plastic pipe down the middle of the wall. Then the walls are critical and the columns. At least half the height of whatever it is 4 meters, must have the tube 2 meters down the middle, and then it hits the bottom. That eliminates splashes and segregation. The compaction is then everything. So I say to them, you put 4 meters ahead of you, 500 thick, start the compaction at one end and then work the rhythm through. And as you go through each layer, don't go back down to the lower layer, because you liquefy the bottom and increase the pressure. And the vertical rate rise has to be between 2 and 3 meters per hour. If they do that, you get blemish-free and very, very good finishes.
The concrete's been poured, and the manager wants to strike it as soon as possible. But striking time is crucial, isn't it?
Vertical work you can take off, and normally a contractor says, I poured tonight, I'll take it off in the morning. With visual concrete, he'll lose the surface because it hasn't set. The starting point is the concrete has to get 12 newtons per millimeter squared hardness before, when you take off the forms, it won't pull away the surface and the corners won't be broken. How do you do that? And I said it's very difficult to make cubes, and I've suggested a simple rule to the carpenters: to use a hammer, and when you get to the top of the wall, you want to check it, bash it. If it bounces off and rings like metal, it's ready. If it goes and it's like soft putty, it's not set. And I would say with the cement replacements we're putting in, 36 hours is about right for curing time, and then strike it. Now, if you then extend that period, and it happens over weekends to say 72, the difference between a panel on the same wall will be, one will be darker than the other. Because basically this is what happens with all concrete, that we put more water into it than we need for the cement to hydrate, because we put it for lubrication. All that water must come out as water vapor. When you have it in formwork and you extend the period, the water condenses on the form face and continually saturates and cures the surface of that concrete. That gets very dark. If you take it off for extended periods, that darkness may take 4 months before the color lightens. So here you have a wall, take all the sheets off at the same period, 36 hours. If you have a whole building space and at one area, take them off at the same time. And I've seen it, and it's on a major project up in Glasgow, sadly. On a big wall, the contractor left 4 sheets for 3 days. And then I was asked, looking at this, why has that happened? I said, because the sheets were left on for that for 3 days, more than this. What will happen? I said, it might take 4 months for that. And they're saying, it's very annoying. I said, I know it is. That's the position. But because the mix is the same, eventually the moisture will come out, and then CO2 will carbonate the surface, because the soffit's the same. A soffit may take 6 months for that to settle in color, and this is another dilemma with architects. The color of the concrete is when the surface is fully dried, just the surface, and absorbs CO2. A soffit's always getting saturated with water, because warm air comes and condenses. Until the building is enclosed, it can't dry out. So it remains quite dark. And then one day, it happens, and you walk in, and it's one color. So eventually I say some of these walls will be the same, but the sadness, I said, is under hydrostatic pressure. That pressure of formwork, which could be 60 or 70 kilonewtons a square meter, it may be so dense it may not ever change color. So what we then try to say is, striking is important, guys. I want you to do it at a point where it doesn't damage the concrete, but strike at the same regime, and don't have to be too late, but don't extend it unnecessarily.
So run us through a few of the defects and problems that could be encountered once the formwork is struck.
First thing is tire wire stuck down there, rusts and you get orange staining. The second is, if you put the spacers in that stick through, you will see spacer marks everywhere, which isn't a good idea. So selecting the spacer is quite a tricky operation. They then go to flat spacers with flat legs. And I said, if you put that in, you see a little square patch everywhere, like a postage stamp. Hello, I'm here. So over the years, I've found this arch-type spacer. It's German. That works because it's got a shallow curve, and the curvature means the pressures on the form face are not high, and the mortar gets underneath and they're invisible. And they tend to use a thing called fabric toast racks to separate the bottom and top bars. You buy these off the shelf, but they rust very quickly. And if you put them in on visual concrete, within a day, and if there's any moisture in there, all the rust will dribble onto the form face, which is now below the bottom mats, and they'll actually sit there and it'll give you a complete orange staining. So I've banned them from being used, and we go back to traditional ways of fixing the top layer with traditional 8mm bars, and that's fine.
So before we wrap up, any final words to architects who may be specifying concrete as an architectural finish?
I sometimes say to architects, when you see concrete first formed, it's very patchy. The only one that will dry out is a column. So if you want to assess the colour, look at a column, and it may take a week or 2 weeks for that to fully carbonate. Your wall may take several weeks, it may take 4 months. So as long as you know the concrete colour is consistent because the mixes are consistent, all you do in the early days is assess the joinery, and you've got no grout loss, you've got no honeycombing, and you've got no black marks. That's great. Then when you do the final arbitration, because you know everything's right, you stand 3 meters away from a wall and you look at it after it's fully dried and carbonated. And then if you see a defect, is it really serious? If it's small, leave it alone. If it's one big blowhole, normally the blowhole should not be more than 2 to 3 millimeters in diameter, and there shouldn't be clusters of them. But I often say, when you see a finished wall, if it overall looks good, don't touch it, because as soon as you try to repair it, it is dangerous. And the first rule I also say to the architect, less is the best. Do not splash too much on it. Leave a few imperfections. It's not a perfect product. And the Alvar Aalto's words were, the imperfections are its beauty. Perversely, he's absolutely right.
David, fascinating stuff, but there we have to leave it. So thank you very much for watching. Until next time, goodbye.